Here in problem 9, they want us to find the zeros of the quadratic function 3x squared plus 10x plus 2, entering our answers as comma-separated lists, incorporating multiplicities. And then they want us to find the zeros of f of x, which is g plug in 2x, and do the same thing. So, well, in part A here, this is a quadratic function. And this one I don't believe factors nicely, so why don't we go ahead and use quadratic formula on that. So your quadratic formula, a is equal to 3, b is equal to 10, and c is equal to 2. And then here is our quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So negative of b will be negative 10 plus or minus a square root b squared, 10 squared, minus 4 times a is 3 times c is 2. And then all over 2 times a, so 2 times 3. So that gives us a negative 10 out in front, plus or minus. This is 100 minus 4 times 3, 12 times 2, 24. So 76 is left there underneath the square root. And then in the denominator, 2 times 3 is 6. Now let's go ahead and simplify that 76. Square root of 76, and see if we got any common factors. We can cancel from top to bottom. So we got a negative 10 plus or minus. And then 76 is divisible by 2, and that'll give us 38, and then that's divisible by 2 again. So this is actually square root of 4 times 19, if you factor that down, over 6. And then we can break the square roots apart. So negative 10 plus or minus root 4 root 19 over 6. So that's negative 10 plus or minus square root of 4 is 2 root 19 over 6. And then notice we got, those are both even, so we got a common factor that we can pull out on top. So we can factor out a 2, be left with negative 5 plus or minus, that should be a 19, not 16. Square root of 19 and then all over 6. So now that 2 cancels into the 6. So this will be negative 5 plus or minus root 19 over 3. So those are the zeros in part A. And then in part B, our function g, our function f, is g plug in 2x. So let me grab our function g. So what we're doing is putting 2x in the place of x. So this is going to be 3 times 2x quantity squared plus 10 times 2x plus 2. And then we can do some simplifying there. 2x times 2x is 4x squared times 3, 12x squared. 10 times 2, 20, 20x. And then plus 2. So that's our new function, and then we want the roots of that. So we're going to use quadratic formula again. And this time our a is 12, our b is 20, and our c is 2. So negative b would be negative 20 plus or minus square root b squared, so 20 squared minus 4 times a is 12 times c is 2. And then all over 2 times a, so 2 times 12, 24. So let's go ahead and simplify some here. So negative 20 plus or minus. So 20 squared is 400, minus 4 times 12 is 48, times 2 is 96. So 400 minus 96, that's 304. So root 304. And then all over 24. And now we have to simplify like we did up above. 304 is even, so you divide that by 2. Keep dividing it by 2. And you get down to, this will be negative 20 plus or minus. And then that 304, that will break up as 16 times 19. So you keep dividing by 2. You can divide 4 times 2 to the 4th is 16. And then divide by 24 in the denominator. And then we can break the 16 and 19 apart. So negative 20 plus or minus root 16, root 19 over 24. So that is going to be negative 20 plus or minus. Square root of 16 is 4. And then root 19 is left. Divide by 24. And then notice that both of those terms in the numerator are divisible by 4. So we've got a common 4 we can factor out. Negative 20 divided by 4, negative 5, plus or minus. This 4 comes out. We've got root 19 left. Root 19, not 16. And then dividing by 24. So then 4 cancels into 24, leaves us 6. So this is negative 5 plus or minus root 19 over 6. And then look what we had up here, negative 5 plus or minus root 19 over 3. So here we're dividing by 6 instead of 3. So we're dividing by a number that's twice as big. That makes the ratio half. So in part C, I forgot to add on part C here. So part C, they ask us what's the relationship between the roots for part B and part C. So the roots in part B are half as big, or half the roots in A. Or another way to say it, the roots in A are twice as big as the roots in part B. So either one of those would be fine.